Find the ultimate bearing capacity, Q, ultimate, in pounds per square feet. In this problem, an infinite strip footing 8 feet wide is buried to a depth of 4 feet beneath the soil surface. The soil is a stiff clay with the given soil properties. Since the groundwater table is not mentioned, it is assumed to be very deep. We begin by writing out our equation for the ultimate bearing capacity of an infinite strip footing. This equation sums the resisting forces from cohesion, the wedge weight, and the overburden of the soil. In this problem, we are neglecting the footing thickness, assuming it to be 0. We begin by determining which variables we need to calculate. Let's begin by solving for the bearing capacity factors for the cohesion n sub c, the wedge weight n sub gamma, and the overburden weight n sub q. In a drained condition, these bearing capacity factors are all a function of the friction angle, phi. Here, I am using the wedge weight multiplier n sub gamma developed by Vesic. We first solve for n sub q, the overburden multiplier, by plugging in our value of phi, 16 degrees. N sub q equals 4.34. The other two bearing capacity factors are solved by plugging in n sub q and phi. N sub c equals 11.63 and n sub gamma equals 3.06. We now have solved our bearing capacity factors. As a time-saving strategy, it may be helpful to print out a table of these bearing capacity factors at various values of phi. Here are the factors we just computed for a friction angle equal to 16 degrees. We next need to determine the effective unit weight and the overburden stress of the soil. Since the groundwater table is not mentioned, we'll set the effective unit weight equal to the total unit weight, which equals 120 pounds per cubic feet. Next, Q, the overburden stress, is calculated. In the context of bearing capacity problems, Q is the same as the vertical effective stress calculated in geostatic stress problems, which is equal to the effective unit weight times the thickness of the soil layer, for all soil layers above the footing base. This unit weight corresponds to the 4 feet of soil above the footing base, which is 120 pounds per cubic feet times the height of the soil layer, which is 4 feet. The overburden stress equals 480 pounds per square feet. Having solved for the effective unit weight and the overburden stress, the ultimate bearing capacity due to general shear failure can be computed. The values are plugged in for the cohesion term, the wedge weight term, and the overburden term. Finally, the bearing capacity computes to 8,204 pounds per square feet. When looking at the possible solutions, the answer is D.